I'm tackling a problem using a linear regression model to predict house prices. We'll use house size to make those predictions. This is the core of the quiz. We'll use information about a model's intercept and coefficient to answer multiple choice questions about its predictions. I'm using a specific machine learning library called sklearn, and more specifically, its linear regression tool. This tool helps me create a model that finds a line of best fit to show the relationship between house size and price. The linear regression model assumes that the relationship between house size and price is a straight line. A simple increase in house size leads to a simple increase in price. I can improve prediction accuracy by adding more information, like the number of bedrooms, to the model. It's like adding more pieces to a puzzle to make a more complete picture. This equation is the heart of our linear regression model. Y represents the predicted house price. X represents the house size in square feet, 50,000 is the intercept, the starting point of the line, and 100 is the coefficient, the slope of the line, showing how much the price changes for every increase in size. This simply clarifies that X is the house size, in square feet, and Y is the predicted price, in dollars, based on the model. This equation represents our linear regression model. Think of it like this. The predicted house price, Y, is calculated by adding a base price, $50,000, the intercept, to the value of the house size, X, in square feet, multiplied by its importance, 100, the coefficient. So, a 1,000 square feet house would be predicted to cost $50,000 plus 100 * 1,000 equals $150,000. This is the core of our problem. We're analyzing a house pricing model and checking our understanding of how it works. Sklearn is a popular Python library for machine learning. Here, we're using its linear regression tool to create a model predicting house prices based simply on size. The model has found an intercept of 50,000 and a coefficient of 100 for the size. The question is testing whether you understand what those numbers mean. Absolutely. This model only uses the size of the house to predict the price. We could likely make it more accurate by adding other details that could influence price, such as the number of bedrooms, bathrooms, location, and so on. This is crucial. Linear regression assumes that the relationship between variables is linear. It can be represented by a straight line. In our case, we're assuming a straight line relationship between house size and price. Let's use the model equation. Y equals 50,000 plus 100x. If x, size, is 0, then y, predicted price, equals 50,000 plus 100 times 0 equals $50,000. So, the statement is correct. Let's check this. The coefficient is 100. This means that for every 1 square foot increase, the price goes up by $100. So, for a 100 square foot increase, the price increases by $10,000. 100 * $100, the statement is correct. This refers to the overall topic, using linear regression, a statistical method, to predict house prices based solely on their size, in square feet. I'll be showing you how this works. Sklearn is a popular Python library for machine learning. Here, we're using its built-in linear regression tool. The problem presents a trained model. The model's already learned the relationship between house size and price from some data. The model has found an intercept of 50,000 and a coefficient of 100 for the size. We will use this information to answer questions about predictions the model makes. This statement checks your understanding of the intercept in a linear regression model. The intercept represents the predicted value when the predictor, house size, is 0. This tests if you understand how the coefficient relates to changes in the predicted house price. The coefficient represents the change in price for a 1-unit increase in size. This assesses your understanding of the fundamental assumption underlying linear regression, that the relationship between variables is linear, meaning it can be represented by a straight line. This statement tests whether you know that adding more relevant features, like the number of bedrooms, to your model could make it more accurate. More information often leads to better predictions. I interpret this as the base price. Imagine a tiny house with 0 square feet. It still has some value, right? This intercept represents that starting value, $50,000. This tells us how much the price increases for each additional square foot. For every extra square foot, I add $100 to the base price. It's the price increase per square foot. This is our prediction equation. Y represents the predicted house price. X is the size of the house in square feet. So, I take the base price, $50,000, and add $100 for every square foot, X. It's like building a house price, brick by brick. This is the core of our problem, using the model to predict the price of a house based on its size. This section introduces the key numbers which define the prediction model. The intercept and coefficient are the building blocks of our linear regression model. I'm using a linear regression model, a common statistical method, to predict house prices. It's like drawing a straight line through data points to predict future values. Here, I'm using sklearn, a popular Python library for machine learning. This is a multiple-choice question testing understanding of linear regression and its interpretation. We've built a linear regression model using sklearn, a machine learning library, to predict house prices using only the house size, in square feet. The model's intercept is 50,000, and the coefficient, slope, for the house size is 100. Now, let's check some statements about the model. This statement is correct. Linear regression fundamentally assumes a straight line relationship between the variables, size and price. In this case, it means we assume house price increases consistently for each additional square foot. Absolutely. Adding more features, like the number of bedrooms, location, or lot size can often help the model better capture the price variations and improve its accuracy. It's like adding more information to paint a clearer picture. This is the equation of the linear regression model I've built. Y represents the predicted house price. X is the size of the house in square feet. 50,000 is the intercept, the price when the size is 0, and 100 is the coefficient, how much the price changes for each extra square foot. I'm just clarifying that Y represents the predicted house price, and X represents the house size, in square feet. This equation describes the model. I predict the house price, Y, by adding a base price of $50,000, the intercept, to $100 times the house size in square feet, X, the coefficient. This shows a linear relationship, a straight line, between size and price. We're using a type of statistical model called linear regression. It's a fantastic tool to predict one thing, like house price, based on another, like size. Sklearn is a popular Python library that we're using here to create and work with this model. If you put 0 for X, house size, in the equation, Y, predicted price, equals $50,000. That's what our intercept means. It's the starting price for a non-existent house, a useful baseline. Linear regression's core assumption is that the relationship between variables can be represented with a straight line. That's why the equation is so simple. We assume the price grows steadily for each additional square foot. Adding more details, like the number of bedrooms, helps create a more refined picture. The model could become more accurate if I capture other important factors that affect house price. It's common practice in building models. This statement is incorrect. The coefficient is 100. That means for each extra square foot, the price increases by $100. Thus, for 100 extra square feet, the price increases by 100 times $100 equals $10,000. I see an equation here that predicts house prices. It's a simple linear equation, where Y represents the predicted house price, 50,000 is the base price, intercept, 100 is how much the price increases for every extra square foot, coefficient, and X is the size of the house in square feet. We use this equation to make predictions. I understand this is the core question of the problem. We're using a linear model to predict prices based on the size of the house in square feet. Cool. This statement checks if you understand what the intercept means in a linear regression model. This option tests if you can correctly calculate price changes based on the coefficient. This statement checks your understanding of a fundamental assumption within linear regression. This assesses if you understand how adding more variables can help improve the accuracy of a model. This is the coefficient for house size, meaning for every 1 square foot increase, I predict a $100 increase in price. This is the intercept, representing the predicted house price when the size is 0. The problem uses a linear regression model, a statistical method that helps find the relationship between variables. In this case, we are finding a relationship between the size of a house and its price.